So there was an error in my previous video, so this video will pick up right at question 3, where we're looking to determine whether each process is exothermic or endothermic in the sign delta H. First, we have gas burning on a stove. So if you put your hand over a fire, that's going to feel hot. That means heat is leaving that fire and going into your hand. Since heat is leaving the fire, it's exothermic and it's delta H. Negative delta H. Alright, so isopropyl alcohol. So our system here is going to be the isopropyl alcohol. So for isopropyl alcohol to evaporate or anything on your skin to evaporate, it'll feel cold. That's why we sweat. What's going on is that heat is leaving your body and going into that liquid. If we define our liquid as a system, that means the liquid's gaining heat. So it's a positive delta H and it's endothermic. And water condensing to steam. So condensation, steam or gas to liquid, is the opposite process of liquid to gas. It's the opposite process of evaporation. So they're opposite in exo and endo as well. When something goes from a gas to a liquid, it has to release heat to do that. So that's an exothermic process and a negative delta H. Right, consider this generic reaction. A plus 2B goes to C plus 3D and delta H is 155. What's the value of delta H for each of these? Alright, so the deal with these are, whenever we change the reaction, our delta H changes. So if you multiply everything in the reaction by a number, so you can see here A went to 3A, 2B went to 6B. We just take the value of delta H and multiply it by that number as well. So our delta H for this is 465. If we flip the reaction, that is, you see C plus 3D is on the products and B is on the reactants, what you do is you flip the sign. If you flip the product and change the number of moles, then you just have to do A and B combined. So first you have to make your 155 negative because you flipped the products and reactants from your target. And you have reduced everything by 1/2. So you see C was a 1 here, now it's 1/2. D was a 3, so it's a 3/2. So you have to take your energy value and also multiply that by 1/2 as well. So that is negative 77.5 kilojoules. And now we're going to do the same idea, but this time we're going to combine two equations. Calculate delta H for this reaction if given the two half reactions. So this game is, can I make these two reactions be combined to make this top reaction? So let's just look at the first molecule in our top reaction, iron oxide, Fe2O3. If we see in our half reactions, Fe2O3 is a product, here it's a reactant. So I need to flip this equation. And the original delta H for this equation was negative 824. So if I flip that equation, that becomes a positive 824.2. So that's what I did. I just switched or flipped the equations. All right, let's look at our second equation. So we have 3CO, but only 1 CO here. So what that means is I have to take this bottom equation and multiply it by 3. And when I do that, I take my delta H and multiply it by 3 as well. Now I can add these two equations. And when you're adding equations, chemical equations, anything on the left side of the arrow, so in both equations, these three molecules are on the left side of the arrow, they stay on the left side of the arrow. Anything on the right side of the arrow stays on the right side of the arrow. And if anything's on the both sides of the arrow, you will cancel them out. For example, in our top equation, we have 3/2 O2 on the product side. In our bottom equation, we have 3/2 O2 on the reactant side. They cancel out. They don't exist anymore. So once we cancel out the O2, our final equation is Fe2O3 plus 3O2, because it's on the same side of the equation, goes to 2Fe, this O2's cancel out, plus 3O2, which is the exact equation we were going for. And for the delta H's, you just add them up. So the delta H, or the heat change in this reaction, is a negative 23.9 kilojoules. And that's all for this problem set. I will see you in the next one.